dust impact may also create another, more serious problem. Long before reaching Halley's solid nucleus, the Giotto probe must plow through the tens of thousands of miles of dust and gas that surround it. And here the bells cooing. Japan's Halley probe, called Planet A, will examine the comet from long distance. It is equipped with two instruments, a camera that senses ultraviolet light and a device for analyzing the solar wind. An even smaller object. At Giotto's high speed, a truly massive dust particle, one weighing, say, a few thousandths of an ounce, striking the outer rim of the dust shield could knock the spacecraft out of its alignment with Earth, causing a loss of radio contact. Giotto would continue sending information until its destruction, but the radio beam would miss Earth entirely. Fortunately, the likelihood of encountering such a heavy particle is very small, if the craft avoids the dense jets of fresh material erupting from the nucleus. These dust jets pose still another problem for those attempting to guide Giotto to the solid core of Comet Halley. Once Halley fell far enough into the solar system for sunlight to evaporate its ice, a coma of gas and dust formed that completely hid the nucleus from observers on Earth. Scientists on Earth may know the position of the nucleus to no better than 300 miles. Astronomers could calculate Halley's position if they could rely on its nucleus to follow a simple path, one controlled solely by the sun's gravitation. The dust and gas spewing from the comet's nucleus, however, preclude its following such an idealized orbit. The outgassing material produces a rocket-like effect that pushes the comet off its predicted course. Giotto's mission analysts predict a 40% chance that the spacecraft will miss its target by more than 300 miles, possibly causing the craft to make an undesirable flyby. Oh, that's a loud damn airplane. Giotto's mission analysts predict a 40% chance that the spacecraft will miss its target by more than 300 miles, possibly causing the craft to make an undesirable flyby past portions of the nucleus not illuminated by the sun. The aim of Giotto's mission is to determine the composition of the coma and the chemical and physical processes within it. Find out the composition of dust particles and the ratio of dust to gas. Provide high-resolution images of the nucleus and investigate the flow of ionized gas in the vicinity of the comet and its reaction to the solar wind. To accomplish these goals, Giotto will carry 10 scientific instruments, including a camera, dust detectors, and several experiments designed to study the electrically charged particles around the comet. The fourth spacecraft to visit Halley will be the Japanese Planet A, launched from southern Japan in mid-August 1985. This craft will fly past the comet about 5 days before Giotto on March 8, 1986, passing far from the active areas Giotto will traverse and approaching no closer than some tens of thousands of miles from the nucleus. Planet A's task is to observe the growth and decay of Halley's coma, measure how fast the cloud of hydrogen atoms around the nucleus expands, and monitor the interaction between the comet's gases and solar particles. Planet A carries only two instruments, a camera that records ultraviolet light and a solar particle analyzer. The camera won't be able to see Halley's 3-mile wide nucleus from the probe's location, but it will provide detailed pictures of the coma's structure. While Giotto photographs the nucleus close up, Planet A will be photographing the surrounding gas and dust in the coma. So, in this picture up here, Blue is the nucleus. 3 is Giotto at 300 miles. And red is Vega's 1 and 2 at 6,000 miles away. You can see the tiny little red dots yonder. And then the nucleus in Giotto. It's going to be real close. The above diagram shows Giotto and the 2 Vega probes at their closest approach to Halley's nucleus. On this scale, planet A would be 5 feet away. So I'm about 5 feet tall, so my arms are about 5 feet long. So I touch the camera and hold the book over here. Man. So planet A carries only 2 instruments: a camera that records ultraviolet light and a solar particle analyzer. Let me back up and make sure I read all of this. The craft will fly past the comet March 8th. Still approaching no closer than tens of thousands of miles from the nucleus. Planet A's task is to observe the growth and decay of Halley's comet, measure how fast the cloud of hydrogen atoms around the nucleus expands, and monitor the interaction between the comet's gases and solar particles. Planet A carries only 2 instruments: a camera that records ultraviolet light and a solar particle analyzer. The camera will be able to see Halley's 3-mile wide nucleus from the probe's location, but it will provide detailed pictures of the comet's structure. While Giotto photographs the nucleus close up, Planet A will be photographing the surrounding gas and dust in the comet. All 4 spacecraft, Giotto, Vega 1, 2, and Planet A, plus the U.S. contribution of ICE, complement one another. The Soviet Vegas are best suited for providing photographs, while Planet A and Giotto are better equipped for experiments involving the comet's glowing gas. In addition, astronomers throughout the world will study Halley from space-borne telescopes in orbit about the Earth, as well as from mountaintop observatories. Halley's latest appearance heralds an unprecedented degree of international cooperation in the exploration of the solar system. Despite this technological assault on Comet Halley, scientists are already looking at more ambitious space missions. The United States, for example, is proposing a rendezvous with Comet Cop, a short-period comet less active than Halley, but much more accessible. All of the missions to Halley are flybys. The probes encounter the comet much as a bullet encounters its target. A rendezvous mission, on the other hand, involves catching up to and traveling alongside a comet for several years, monitoring all of its subtle changes as it circles the sun. The space probe currently envisioned would use parts from previous U.S. space missions and would follow Comet Cop for 2 years. But that lies years in the future. Right now, we don't yet know what the missions to Halley will find. It's safe to say, however, that the data they will return will answer the most obvious scientific questions. Just as surely, the missions will raise a lot of new questions that delve even deeper into the mystery of the nature and origin of comets. Is this what a comet's nucleus really looks like? Photographs from Giotto's perilous mission may tell us. Halley swings across 3/4 of the sky in only 7 months after spending years moving only a few degrees. Its motion across the sky reflects not only its own motion around the sun, but that of the Earth as well. As Earth moves around the sun, the comet traces a loop because Halley is close to us relative to the very distant stars. Plunging through Dang it. Stupid thing. The path of Halley's Comet across the sky from 1982 to 1987. Halley swings across 3/4 of the sky in only 7 months after spending years moving only a few degrees. Its motion across the sky reflects not only its own motion around the sun, but that of the Earth as well. As Earth moves around the sun, the comet traces a loop because Halley is close to us relative to the very distant stars. Plunging through the inner solar system, Halley makes its closest approach to Earth on April 11, 1986, 2 months after it swings past the sun. In 1986, they didn't yet know what the missions to Halley would find. It's safe to say, however, that the data they return will answer the most obvious scientific question. Just as surely, the missions will raise a lot of new questions that delve even deeper into the mystery of the nature and origin of comets. Is this what a comet's nucleus really looks like? Photographs from Giotto's perilous mission may tell us. This is a lovely painting. But what the AI told me is that it is a potato-shaped object in space that is so dark, it's darker than coal. Special thanks to Ruth Freitag, Science and Technology Division, Library of Congress, and Steve Edberg at JPL. Further reading: Introduction to Comets by John C. Brandt and Robert D. Chapman, Cambridge University Press, London, 1981. Two NASA astronomers give a comprehensive, fairly technical introduction to cometary science, past and present. The Comet Book, a guide for the return of Halley's Comet by Robert D. Chapman and John C. Brandt, Jones and Bartlett, Boston, 1984. A popular non-technical version of the above book. Comets, edited by Laurel L. Wilkening, University of Arizona Press, Tucson, 1982. A 766-page volume of technical papers on various aspects of cometary research. Comets, a descriptive catalog by Gary W. Cronk, Enslow Publishers, Incorporated. Hillside, New Jersey, 1984. This book contains detailed descriptions of more than 650 comets, including basic scientific and historical information. Edmund Halley by Angus Armitage, Thomas Nelson and Sons Limited, London, 1966. A detailed semi-technical account of Edmund Halley's life and work. Edmund Halley, Genius in Eclipse by Colin Ronan. Doubleday, New York, 1969. A biography of Halley intended for a general audience. Article: Backtracking the Comet by Francis Reddy, Astronomy. August 1982, pages 6 through 17. Brighter Prospects for Halley's Comet by John E. Bortle and Charles S. Morris, Sky and Telescope, January 1984, pages 19 to 12. The Cometary Atlas in the Silk Book of the Han Tomb at Mawangui by Ji Zezong, Chinese Astronomy and Astrophysics, March 1984, pages 1 through 7. Comets, Death Stars, and Extinction: The Rise and Fall of a Scientific Theory by Ray Grasshoff, Astronomy, March 1985, pages 18 to 22. Comets, Keys to Our Solar System by Deborah Malloy Emmelgreen, Astronomy, March 1985, pages 6 through 17. Malloy? Four Probes to Comet Halley by Jesse Eichenlaub, Astronomy, September 1983, pages 16 to 22. Giotto's Portrait of Halley's Comet by Roberta Olson, Scientific American, May 1979, pages 160 to 170. Observing 8, Sky Calendar. Abrams Planetarium, Michigan State University, East Lansing, Michigan. This monthly publication provides simple maps for finding the moon and planets. The Star Book by Robert Burnham, Astromedia Corps, and Cambridge University Press, Milwaukee, 1983. An introduction to the constellations visible from the northern temperate latitudes, containing 8 sky maps, 2 for each season. Keep tabs on Comet Halley's progress with astronomy, the most popular English-language magazine about astronomy and outer space. A very good book. Very interesting to see what was going on the year before I was born. All these lovely old photos. This book was supposed to have in it a model to construct between these pages, but it doesn't here. I did look up a copy of this on Amazon. There's a few out there. Maybe they still have their models in them. Established returns of Halley's Comet. Date of perihelion. March 30, year 239 BC. October 5th, 163 BC. August 2nd, 86 BC. October 5th, 11 BC. January 26, 66 AD. March 20th, 141 AD. May 17th, 218 AD. April 20th, 295 AD. September 16th, 374. June 24th, 451. September 25th, 530. March 13th, 607. September 28th, 684. May 22nd, 760. February 27th, 837. July 9th, 912. September 9th, 989. March 23rd, 1066. April 22nd, 1145. October 1st, 1222. October 23rd, 1301. November 9th, 1378. June 9th, 1456. August 25th, 1531. October 27th, 1607. September 15th, 1682. March 13th, 1759. November 16th, 1835. April 20th, 1910. February 9th, 1986. Come. In the 16th century, engraving Melancholia 1, artist Albrecht Dürer set a brilliant, dynamic, but not very realistic comet into the background. And it's showing its light coming from many directions. That's just the way he was doing the sky. It's an engraving, after all. No one knows how many times Halley's Comet has blazed across our skies. The earliest probable reference to it appears in the historical record, a Chinese book of observations compiled in the 1st century BC. A brief passage notes simply that a Huixing, a broom star, appeared for several weeks in the 7th year of Emperor Xian Shuhong, 240 BC. The term broom star was used for a comet with a prominent tail. The ancient Chinese had a very sophisticated astrology. Since broom stars were believed to portend great change, the astrologers made detailed records of their size, shape, and motion through the sky. The accuracy of these observations was not matched in the West until the 15th century. Such records are an invaluable resource for astronomers interested in long-term studies of comets. Strangely, there are no records of Halley's return in 164 BC. Astronomers believe the relative positions of Earth, Sun, and Comet created such a poor geometry that Halley could not be seen. It was, however, well observed on its next return. In 86 BC, when Julius Caesar was a boy of 14, Halley's comet terrified the citizens of Rome, the earliest unambiguous sighting of the comet. Comet Halley appeared in 1145 while the monk Edwin was copying the Psalms from earlier Utrecht Psalter. Along the bottom of the page containing Psalm 5 in Edwin's Psalter is a sketch of a comet and a brief description. Although this picture was inspired by the comet's 684 appearance, it wasn't actually executed until 1493. It appeared in Hartmann Schettel's Nuremberg Chronicles. Here's both the pictures. You can see the comet at the bottom of the Psalter. Lovely artwork. What's more? Let's take a look. Okay. 1145. April the 22nd. And this one was 684. September 28th. The Bayeux Tapestry contains the earliest known contemporary portrait of the comet. Measuring almost 231 feet long by 20 inches wide, the tapestry, only 20 inches wide, and 231 feet long. The tapestry was commissioned by Queen Matilda, wife of William of Normandy, to commemorate her husband's victory at the Battle of Hastings in 1066. In one scene, Englishmen marvel at a stylized comet, while an aide informs Harold II of the bad omen. Harold II? This is Harold II. Work on the piece began in 1073 and took a decade to complete. 231 feet long. The tapestry now hangs in the town hall of Bayeux in Normandy. Comet Halley didn't do England's King Harold much good, but William, now surnamed the Conqueror, had nothing to complain about. The Bayeux Tapestry. I'm French. Je suis acadien. The legend near the stylized comet reads, "They marvel at the star beneath the comet." An aide informs Harold II of the omen. So Halley's appearance in 1066 was later viewed as a portent of doom for England's Harold II. This stella is probably the word for star. Okay. Isti Mirant. When Halley appeared in 1531, medieval Western astronomers finally realized that the comet tails always point away from the sun. And in Cometographia, Hevelius included a sketch of Comet Halley at its return in 1607. The true nature of comets and their orbits was a hot topic in the 17th century. This illustration from Johann Hevelius' Cometographia published in 1668. 1668. So between the October 27, 1607, and September 15, 1682 appearances. Shows three scientists debating the issue. The man on the left holds that comets are very near the Earth, as Aristotle had suggested. The one on the right agrees with Kepler's view that comets move in straight lines. The scientist in the center argues that comets move in parabolas, the view put forward by Halley himself. But none of them were right about it. Look what's going on up here. Beautiful artwork. Some people with some instruments observing the sky and the comet. And these fellows arguing about mathematical models. And then there's the comet, third from the top. And let's see, eight comets. And the German astronomer Otto Struve made this detailed sketch of Halley's appearance through a telescope in 1835. November 16th. And I wrote this nice German text about it. January 1759. Hamburger's magazine announced Johann Sauer's recovery of Halley's comet. Edmund Halley's full prediction had come true. So, here are ellipses, parabolas, and hyperbolas are all shapes formed by slicing through a cone at various angles, conic sections. It's hard to tell the difference between orbits shaped like the conic sections, especially very near the sun where an orbiting comet would be bright enough to be seen from Earth. And here, these pages from Edmund Halley's notebook contained his original observations of the comet that bears his name, and Halley's orbit for the comet of 1680 as appears in Newton's Principia. Here's the man, the myth, the legend. Edmund Halley. At the age of 33. Here's his notebook. They could have printed it bigger. And here's Newton's. Here, an alarm for Europe. Cometary and comet. It's in October and May, and Halley's track around the sun. Comet dust in Halley's orbit. And Earth, the Moon, Lexel, 1770, 1.4 million miles. Iris, Araki, Alcock, 1983, 2.8 million miles. Hans Winnecke, 1927, and Halley, 837, 3.7 million miles. 37. February 27th. And the reliable meteor showers. Shower name Eta Aquarid. The date it peaks May 4th. Hourly rate 20. Perseid August 13th, 50. Orionid October 20th, 25. Leonid November 17th, 10. Geminid December 13th, 50. So it is the Eta Aquarids and the Orionids that come from Comet Halley. Leonids on November 17th, hourly rate 10. The Leonid shower usually generates 10 meteor trails an hour, but in 1833, when Earth passed through a dense part of the swarm, 200,000 meteors fell from the sky in just 9 hours. The most recent such display occurred in 1966, but the next isn't due until the late 1990s. When I was a little girl, I would like to look up the Leonid meteor showers. Let's see what we can find, huh? Oh, the Artemis 2 mission's going on right now. Artemis 2 reports seeing impact flashes. See, me shower. 1833. Oh yeah. And 1890. I'm gonna put 6 because I'm seeing 6 here. The 1833 Leonid meteor shower was the most intense storm in recorded history, up to 100,000 meteors per hour seen across North America, causing widespread panic and launching the scientific study of meteor showers. While the 1966 storm, often confused with 1966 and 1999, was also spectacular, the Leonids typically peak every 33 years. So November 12th, 13, 1833, the intensity to estimates range from 50,000 to over 100,000 meters per hour, lasting for about 9 hours. Impact: the sheer volume of falling stars was so intense it caused fear of the apocalypse. Scientific significance led astronomers to realize that meteors are extraterrestrial, not atmospheric phenomena, marking the birth of modern meteorology. Cause: Earth passed directly through a dense, fresh dust trail left by Comet 55P Tempel-Tuttle in 1799. Leonid activity around 1966. The 1966 storm, a massive, similar, or even more intense outburst occurred on November 17, 1966, over North America, with estimated rates of 40 to 50 streaks per second, over 100,000 per hour. 1966 activity. 1996 activity. While 1996 did not produce a storm on the scale of 1833 or 1966, it was part of the lead-up to the highly active Leonid storms of 1999 to 2002. 1990 showers: the Leonids returned to strong but lower-level storm activity in the late 90s as the comet returned to the inner solar system, with a notable peak of less than 3,000 meters per hour in 1999. They both happened, both the 1833 and 1966 storms happened because Earth intersected dense debris paths from Comet 55P Tempel-Tuttle. Okay, so there's an Oxford academic paper on this. and a YouTube video. Oh yeah, the most recent such display occurred in 1966. The next isn't due until the late 1990s. Yeah. Okay, so let's see. Tell me about the 1999 to 2002 storm. So, TEOR. Show. Okay, it's acting weird now. Astro. Please. Please. Tell about media. UE. Showers. 99. And 202. The 1999 and 2002 Leonid meteor showers were spectacular meteor storms triggered by the return of their parent comet 55P Tempel-Tuttle in 1998. While both years met the official storm threshold of 1,000 meteors per hour, they offered very different viewing experiences based on location and meteor characteristics. The 1999 Leonid meteor storm event is famous for being the first major storm successfully predicted using modern dust trail modeling, which allowed astronomers to time its peak within minutes. Peak intensity reached an equivalent of zenithal hourly rate of about 3,700 meteors. Best locations, prime viewing was in Europe, North Africa, and the Middle East. Visual character, the storm was noted for a high percentage of fainter meteors compared to previous years. Despite this, NASA researchers flying over the Azores described the sky as on fire, with rates of up to 5,000 shooting stars per hour. Timing the main peak occurred around 2:02 UT on November 18, 1999. The 2002 Leonid meteor storm is recognized as the last true Leonid storm of recent memory, with the next significant event not expected until the 2030s. Twin Peaks. Unlike 1999, the 2002 event featured two distinct outbursts as Earth passed through two separate dust trails. First peak at 4:10 UT, November 19th, favoring Europe and Africa, caused by the 1767 dust trail. Second peak at 10:47 UT, November 19th, favoring North America, caused by the 1866 dust trail. Peak intensity, the ZHR estimates for both peaks range between 2,500 and 3,500